Welcome back, everyone.
Hello! How many energy drinks did everyone consume? 4? Anyone consume more than 4? Anyone consume 5? Okay, nice and in. All right.
Hope you're excited to hear the winners for this hackathon. Before we keep going, our agenda for today, we'll first have an incredible keynote speaker spread his wisdom about his experiences, then go on to the incredible 9 finalists who have worked really hard to be here and get to this final stage, and finally get to the awards. So recapping this weekend, here are some incredible photos that we have snapped. Many more will be released at the end of this event. See if you can spot yourself.
Give yourselves all a big round of applause. Well done this weekend.
So let's recap who was at AI Hackathon. We had over 1,300 hackers join us for this incredible weekend, 400 which were first-time hackers. So give them a big round of applause for taking this big leap. This event also would not have been possible without our almost 180 volunteers, 100 judges, 100 mentors, 30 directors, 20 sponsors, and of course, our big bear. And special thank you to our sponsors, all listed up here. This event would not have been possible without their support. So please give them a round of applause.
Thank you.
Alrighty, I'm very excited to introduce our keynote speaker for today, Anastasios, who is the co-founder and CEO of LMArena. So give it up for him.
And also a UC Berkeley alumni, so go Bears!
Hello, everyone. You can hear me? Yeah? Good. Well, thanks so much to the organizers for inviting me. It's great to meet all of you. First thing I'd like to say is it smells amazing in here. It's just wonderful. It's the combination of body odor and cologne that you only expect from a hackathon. So wonderful to meet all of you, and exciting, to be speaking to this crowd. So, yeah, first of all, my speech is like the least interesting thing that you guys are going to be seeing today. Congratulations to all of you on an incredible event, and to the organizers for a wonderful hackathon. I know that this is a huge amount of work to put on, so let's have a hand for them. Yeah, really incredible work. So, getting into it, let me tell you a little bit about me before we go into the content of the talk. So, I'm a bear, go Bears. I was born in Berkeley, then I moved to LA later, grew up there, and then came back. Came back for my PhD in machine learning. I fell in love in Berkeley. My future wife, my fiance, is sitting in the audience right here. We met as part of the PhD program. And I started my company as a quintessential Berkeley company with a group of students and collaborators and professors here. So Berkeley has given me a lot. It's an incredible place. I have a lot of love for it, and I'm excited to be here speaking. So now let me tell you a little bit about LMArena, which is the company that I've been working on, as a research project through Berkeley for the past couple of years, and now newly as a startup. So I'll show it to you via demo. If you go to LMArena.ai, this is what you're going to see. It's just a chat interface. I'm sure you guys are familiar with these, given it's the AI hackathon, right? And if you type something, you can say, hey, what are some good ideas for an AI hackathon? Keep it concise and give me 5. We'll see if any of them parallel things that you guys came up with. Okay, so it says an accessibility tool, a medical symptom journal, a code review, and then I'll say, which one would win the real Berkeley AI hackathon? Okay. And we'll see what happens here. It's thinking, and it says, okay, the AI-powered accessibility tool. So you'll see these are 2 anonymous LLMs sampled from a pool, Assistant A and Assistant B. And then for Assistant B, which I'm going to choose because it's a little more concise, and I like the mental health tool, that was Claude 3.7, it'd be Claude 4.0. Now there's 3 valuable pieces of data there that we use to construct a leaderboard based on this. There's the prompt, there's the 2 responses, and then there's the actual human vote. And you'll see what we do is we use regressions like Bradley-Terry regressions and so on to turn this into a leaderboard. The #1 model right now is Gemini 2.5 Pro. Then you get into O3, the last version of Pro. The #6 model is Claude Opus at 1419. The score higher is better. It's basically a pairwise. It's like a reward model if you guys use those. And then there's also different categories. There's creative writing, there's coding, and so on. And then we also run certain like controlled regressions on it. So if you want to understand, hey, which model's best for me, and I don't care about style, you can remove style control. The style control is a filter that we put on to say, can we disentangle style and substance, only show the style? And you'll see it has a big effect on the leaderboard. Like when you take away the effect of style, Claude goes up quite a bit. Now, it's not just text that we do, it's also image generation, image editing, and other modalities. I'll do a fun one here. So I'm going to go on the internet and find a picture of the Chancellor, Lyons. I'm going to put it in there and say, put his tongue out. And we'll see what happens. We'll see what it generates. So it's thinking here. I'm sped it up. Oh, nice. Okay, so on the left, it's wonderful. It's beautiful. Scooby-Doo tongue. Okay, or taco tongue. Taco tongue is also good. But I'm going to choose the one on the left. Okay, and then the identities are again revealed. So you can see it's like a blind force choice testing platform for the purpose of evaluating AIs. Now another thing, because you guys are hackers, you guys must be familiar with tools like Replicant, things that are going to, allow you to build an app in like, however many seconds instead of coding it yourself. Now this is a Replicant arena, we call it Web Dev Arena, that we built here. And it was actually built by, I think, an alum of this program, Aryan Bichare. They're saying, yep. And so it's like, it'll pop up two, and then you can choose between them. I said, make a hackathon submission. This one's a little weird. It's not exactly a submission. It's more like a website. Okay, it's got the prizes. Okay, I can't find my talk in there, but that's all right. Alex Johnson, CTO of DeepMind. I don't know who that is. And the buttons don't exactly work. They'll take you back to the top, but it's okay. At least it compiled, so I'll click right is better. That's where we're at. So if this tells you anything, your jobs at the moment are safe, because neither of these websites or submissions is really good. So can an AI win Berkeley Hackathon? Probably not. Now, the platform that I just showed you, it's a bunch of AI evaluations across different modalities: text, image generation, web development. We also have red teaming. We have in-context coding, like a Copilot arena. And it's been run, it started as an open source project at Berkeley. It started just as a bunch of students working together. And after 2 years, it's grown into a pretty large platform. It's got more than 1 million monthly users. Over 150 million conversations have happened on the platform. About 1 to 2 million more conversations every week happen. And it's a trusted leaderboard by basically all major model providers. So we work with all major model providers to evaluate their models, sometimes pre-release, sometimes at the moment of release. That includes the OpenAIs and Googles and Anthropics, the Mistrals, the Metas, the XAIs of the world. And you might have seen LMArena online. It's kind of a, we're active on Twitter, and a lot of people are, generating conversation about it. Now, the question is, how did we get here? How did LMArena become what it is? And how did it grow out of the open source project that it was, a bunch of PhD students working together, into the platform that it is today? And where is it going? And the first order answer to that question is it started in a hackathon. Okay, so what happened is that some students at Berkeley and Berkeley Skylab were working on this open source chatbot, Vicuña. That was one of the first open source chat-tuned LLMs. And in the process of that, they realized, like, hey, how are we going to prove that this LLM is actually any good? How are we going to prove that it's better than other offerings that are out there, or even non-chat-tuned things? And what they realized is that a lot of it is subjective. The LLM is interacting with a human, and so you need human evaluations in order to tell what's happening. And so that's the birthplace of LMArena. And you can see that's the first tweet about it in April 24th, 2023. It says, introducing Chatbot Arena. We've released Vicuña, and there's all these other LLMs. Come try them in one interface. And, I initially approached the project, I was doing machine learning. I was doing like statistical theory and stuff like that. And so when I saw this project, I was like, hey, what a cool opportunity to like develop methodology, new statistical methods in order to try and address the problem of evaluation in the world of LLMs. You know, it was exciting to me, and also I liked the people, and it was like, hey, I have a little bit of time on my hands. It was like referred through my PhD advisor. Why not spend some time doing this like wacky side project? And so I first met with my co-founder, Wei Lin, and Jan Stoika, and we filled up 3 whiteboards filled with, you know, just math problems, statistics problems that, you know, we weren't necessarily developing new things, but how are we going to take all these votes and turn them into a regression? How are we going to construct the leaderboard? How are we going to form the confidence intervals? And, you know, 2 years since, now I spend like all my time running this platform along with a wonderful team. Now, a hackathon is not enough. After the hackathon, the project went, ooh, and you know, there weren't as many votes. There was just some initial interest, and then look at the plot. It's like, you start in May, you go to July and September, and the curve is down, guys. That's not like, this is not the hockey stick that we were, you know, necessarily anticipating. But credit to Wei Lin, you know, he had enormous consistency in making sure that this platform continued developing. At some point in the middle of the summer, he said, hey, I want this to be, you know, I want to work on this full time. And he started adding models, improving the platform, tweeting about it, increasing the distribution, you know, every day, little improvements. And you know, I joined him around that time too. And then, you know, that led to a little bit of growth. Then we were like, hey, let's take it to the next level. And we started living together. So we moved in. This is Wei Lin's birthday, like last year. You know, along the way, it wasn't just us. It was a huge group of Berkeley PhD students and undergrads and master's students that were working on this platform as it continues to grow. And, you know, you can see the spikes there. These often have to do with competition. So we were at the right place, right time. As, you know, maybe it was just ChatGPT at the beginning, but once Meta got in the game and Anthropic got in the game and so on and so forth, interest in comparisons and evaluations skyrocketed. So that's the way, you know, the curve grew and grew and grew and grew. And we also started pre-release testing models. So our community loves seeing new models before anyone else. And so they come onto our platform with code names. I don't know if you remember, like, you know, I'm a little GPT and that whole debacle, but that happened on our platform. And it was amazing. That's the other spike in traffic that you see there. And since last year, we've, you know, continued to grow it and improve it. Now, another question that you might have is, why did LMArena even resonate? You know, I showed you the polished version of the platform, but the early version of the platform that we built was a research prototype. It was a Gradio app. And, you know, credit to Gradio. Gradio, I'm sure a lot of you guys are way better at interface design than we are. And the Gradio app that we had allowed us, from a research perspective, to take the platform from just an idea we had in our head directly into code and scale to like millions of users. And then only recently have we transitioned into like Next.js and all these frameworks that you guys are probably using for your hackathon. But why did it resonate? Why did, you know, despite the fact that we're not exactly the world's best consumer product people, why did this turn into, you know, such a phenomenon? And I think that for that you need to zoom out. We're in a new age of software. Software is changing. Unit tests are not enough for us to evaluate our software anymore. Because the way that our software works, you have humans inputting these super subjective prompts, asking you to do things that maybe don't even make sense, they're not precisely defined. And so ultimately, at the end of the day, because they're interacting with humans, you need humans at the other end evaluating them. The space of things that you're doing is too broad. It can't be just ImageNet, like classify, or MMLU, I'm going to look at multiple choice question answering. You need to have something that goes beyond and captures the diversity of uses, you know, that LLMs are being subjected to on a day-to-day basis. So this leads us into LMArena. You know, with static benchmarks, the way they work is you look at a vertical. I'm going to collect the data set, and then, like, I'm going to test the model on the test that I come up with. But the issue with there's just differences, okay? These static benchmarks are useful for evaluating these narrow verticals, but at the end of the day, live benchmarks may also be useful. And in fact, I would say that these are the benchmarks of the future, not just ours, but many. So what are the ways that they differ? Static benchmarks, for example, lend themselves to overfitting. if you create one test and you test the LM over and over and over again on the same test, what ends up happening is it memorizes the answers, and then the test doesn't become a good, a good judge of whether or not the LM is good at the underlying task distribution. Live benchmarks, though, like LMArena, are different. We have millions of people coming to the platform giving fresh prompts all the time. And because the data is fresh, that guards against this overfitting, because you're constantly getting new questions from the distribution of test questions that you're supposed to be good at. Now, another issue with static benchmarks that we're starting to see is contamination risk. As soon as you output, as soon as you create a static benchmark, you publish it on the internet, chances are that because the LMs are trained on the whole internet, that somebody's seeing it and training on it. But with live benchmarks that are created via people like us going to the website and asking whatever questions on our mind, there's no contamination based on those, right? Because the questions are always new. Now, one benefit of static benchmarks is that they're targeted, whereas live benchmarks are organic, right? You're getting whatever people want to ask. It might be something that you're not even interested in, or it might be something that you didn't know that you were interested in, or that somebody else in the world is interested in, someone else is not. Static benchmarks also lend themselves well to rubrics, right? People don't come to LMArena to say, I want to, give data. People are coming to LMArena because they love using the best AIs and comparing them and looking at the leaderboard and getting multiple opinions from all the best AIs in the world. So natural usage data often does not lend itself well towards asking people to do things they don't already automatically want to do. And static benchmarks, often they're constructed via paid annotators, whether that's a graduate student that's sitting for days and days labeling images of dogs and cats, or that's somebody that you actually hire to say, hey, you're a radiologist, come in and label images. Live benchmarks are different, though. They're just like random people on the internet. So, in other words, this is where we are with the platform today, but there's a number of challenges that we need to resolve for the future. How are we going to take these features of live benchmarks, the fact that they're organic, the fact that they're determined by, just random people on the internet doing whatever they want to do, and turn those into features? And I'm going to dig in a little bit on one of them, which is targeted evaluations. How can we take all this organic data that we have and turn it actually, basically invert the problem of evaluation? Turn it into a problem of, I'm going to go target a task and I'm going to collect, spend a lot of money to collect a data set for it. Instead of doing that, maybe what I want to do is say, hey, go use the LLMs however you want. I'm going to generate a bunch of data from this organic usage, and I'm going to analyze it. I'm going to basically mine it for insights as to which LLMs are good at different parts of the space. And then you start getting into the questions that are really interesting to people like us, developers and scientists, which is how do we create very personalized evaluations that are telling you which model is best for you, which model is best for your use case, for people like me. How are we supposed to answer this question? And it's a tough question. One way that you can ask the question would be to say, you give me a prompt. You give me, I want my hackathon project about, a personal assistant that's going to help me schedule things in my calendar. And then I'm going to tell you which model is best exactly for that use case. But the problem is you might be the first person doing what you're doing. That might be the only time I've ever seen that prompt ever. And so the standard paradigm of regression won't work, because regressions don't work on data points that I've never seen before, right? You need to run empirical risk minimization, you need to calculate, you need to have your loss function, you need to minimize and so on. That's not the way that this is going to work. So it seems like a hard problem. But it turns out that there's a way to solve it, and this is where it's useful to have, Berkeley people on the team that are great scientists. Because what our team has done is we've developed a way of training a large language model to take prompts as input and output leaderboards, even if those prompts have never been seen before. So the idea basically is parameterizing the Bradley-Terry coefficients, these regression coefficients, as a language model. Can we train language models to intrinsically output leaderboards by nature? And the way that it works is basically a creative way of supervising via your loss function. Okay, so the only thing we observe, remember, is pairwise preference data from Chatbot Arena. Left-right votes. Is model A better or is model B better? And what we end up doing is we're saying, hey, let's call the prompt P. Let's put it through an LLM. You'll get theta of P. Theta representing the leaderboard. It's a vector of length M, where M is the number of models in your leaderboard. And then what we're going to do is we're going to supervise it via binary cross entropy in order to try to predict the votes that we see. So if theta P is good, this model, which is like sigmoid of theta P transpose X, that model is going to be good at predicting whether or not you voted left or right. And if the leaderboard is bad, it won't be good. And so the loss function is going to tell you that. Loss function is high when sigmoid of blah, blah, blah does not agree with y. Right? That's how the loss function works. And it turns out that that loss function is differentiable. So you can apply the standard toolkit of deep learning in order to make sure that loss goes down and you're learning leaderboards that are good at predicting. Okay, so what we end up doing is we actually just train a language model end to end, supervise it in order to do this task. And you train it with backprop just as normal, and theta p then becomes a prompt-specific leaderboard. Now, what's interesting about this? Why did I just tell you this technical story? It's because as we're developing these AI apps, there's a lot of interesting and important research questions to do along the way that are really going to change the way that we build our software. So one of the insights that we had while doing this is to say, hey, by doing this, by turning evaluation into a problem of learning instead of a problem of averaging as you would normally think about it, we benefit from scaling laws. We can have scaling laws for evaluations, and that's exactly what you see. If you train, a 500 million parameter model to do this leaderboard prediction task, it'll do well, it'll do better than the standard regression, but not nearly as well as a 7 billion parameter model, and so on and so on. And the more data you get, the better it gets. So we're benefiting from ever more granular evaluations that are better at telling you which model is best for you and your app via this new scientific methodology that we developed open source at Berkeley. So last thing I'll say, takeaways from this is, this was just a hackathon project at first, and now it's become a real company, right? We have, more than a dozen employees. We've raised money. More money, more problems, of course, but things are off to the races. Now we have to demonstrate that this platform's useful. We have our 1 million users, our community that we're digging into. The first thing I would say is you have to stay consistent. If you looked at the plot I showed you earlier, the platform almost died. And it would have died if not for, Wei Lin and others supporting it along the way. So if you come out of this and you build your hackathon project and you say, hey, I'm not going to maintain this, it will die, and then nothing will come of it. But if you do maintain it, who knows? It might go dip down and then come back up, just like ours did. The second thing I'll say is just find the best team. One of the things that we're really proud of is that our team is built of pretty low ego people that are looking for people better than them at every task. Willin and I know that we're not the best consumer product people. We know that we're not necessarily the best at UI. We know that we're not the best at backend, but we need to find people that are better than us at this. And in fact, you want to find other people that are continue to create this low ego environment where you guys are building a team serving a greater mission than yourself, right? So go take your hackathon project, go find the best people in the room, work together on something that's going to become greater than the project that you built over the last couple days. And the last thing I'd say is keep adapting. The world's going to teach you how to change, right? You have to listen to the feedback the universe is giving you in order to continue improving the application that you guys are building. So those are my 3 takeaways from my project. And your mileage may vary. It's not like we've had massive success yet. But we'll see where it goes, and looking forward to hearing from any of you on how your projects go to the moon. Appreciate it.
Thank you so much. All righty. And now for the moment you all have been waiting for. We have our 3 grand prize tracks, the creativity track, the developer tools and productivity track, and the social impact track coming up. We'll have 9 finalists pitching to you all, to a panel of judges who will be seated over here. And they each stand a chance to win 5K in each of these tracks, which totals up to 15K. Alrighty. Cool. So as I mentioned, the pitch process is going to be 9 finalists coming up on stage. They'll pitch for about 3 minutes, and then they'll have 3 minutes to talk to our judges. And speaking of our judges, please meet your grand judges. If we could have them come out. We have Carl Choi from Alumni Ventures. Let's give them a big round of applause. James Alcorn from Lightspeed. Mark Astor, the Dean from the College of Engineering. David Bloom from the House Fund. Liz Wessel from First Round Capital, and lastly but not least, Alex DeMarcus from UC Berkeley Eats. Awesome. And now I believe it is time to introduce our first team. Cool. Yep. As their slides come on right up. Our first team is Chip Chat. Let's give it up for Chip Chat.
Hi everyone, thank you for joining us today. My name is Yashna.
I'm Aditi.
I'm Olga.
And I'm Lucas.
And we are Chip Chat. Thank you. So as you know, hardware serves as the backbone for nearly everything in society today: medicine, telecommunications, memory, energy, and it's only going to be playing a more important role. I've been in a microchip lab for the last 2 years at Berkeley, and I've realized that PhD students have spent 6-7 years iterating over the same microchips again and again. And, sorry about that. And students in 61C have taken months to build that intuitive circuit design knowledge, and companies like Meta have spent over $46 billion on Metaverse and over 5 years to develop chip technology for glasses like that.
Now, let's do it in 10 seconds. Let's take the example of a 4-bit adder circuit. We begin by inputting the circuit we want to build. Can we play the video, please? We begin by inputting the circuit we want to build and wait for Gemini to produce a result. First, Gemini produces a Verilog file summarizing the circuit logic. Using a custom pipeline, we process the Verilog file to produce an interactive logic circuit. In this 4-bit adder circuit, you can select the inputs, simulate the circuit, and verify the outputs. 2 plus 2 is indeed 4. Next, we synthesize our Verilog files to include information about the logic gates. We continue our chip generation process by creating a .def file to include information about the position of individual circuit elements. Lastly, we produce a .gds2 file that represents the circuits in 2D and 3D, planning the real estate of the circuit. This GDS2 file is now ready for fabrication.
You can play the video. So within the chip chat, we have a circuit assistant where you can chat for educational purpose to understand the circuit. And it has the multimodal agent file where you can upload the schematic drawing and it will generate from very low code to the physical chip design. So you can go from this to this.
So to summarize, our proprietary workflow starts by using Letta with Gemini as its model to generate the Verilog code. And then we use a bunch of libraries to generate the GDS file, the interactive circuit, and the physical layout file.
Today, going from circuit idea to GDS2 file takes about 2 or more years. We need to cut that down to 2 months, so we use AI agents for that. There's higher demand but less supplies, as there's massive shortage of chip designers and hardware engineers. We don't want to replace them, but we want to help them create faster tools to focus more on the architecture of the GDS2 file, ready for fabrication.
We strive to take chip chat to the next level by incorporating verification, higher compute, and higher processing to bring this to a full-scale end-to-end CPU and GPU development pipeline for engineers everywhere. Currently, they spend over 50% of their time on verification and development, and with chip chat, we see that students, engineers, and everyone interested in hardware can enter the gateway and turn their ideation into fabrication. Thank you.
Can you talk about how you think about the monetization of this business? Who would you sell to, and where would budgets come from?
So currently, I think it's really important to make this tool open source, particularly for students. right now, with the state of our current models, they don't necessarily support the ability to make large open source, large CPU or GPU files. So we might focus on education for now, and later on branch to GPU, CPU, and potentially machine learning hardware accelerators.
I can add on to that as well really quick. All of that, in order to build the full-scale end-to-end pipeline, requires money and data, so that comes with time, and as soon as we have that, we would love to take this further and help build that. Yeah.
Can you tell us a little bit about the stack that you used? You have some, like what tools you used in the technical AI stack?
Yeah, so to generate the initial Verilog code, we used Leda with Gemini as model. And the reason for this is that Leda makes it really easy to incorporate things like chain of thought reasoning, first of all, to help it tackle like more complex problems, like kind of like how Cursor will think and reason before actually generating a solution. It can do something similar and split into smaller steps to generate larger circuits. And also makes it easy to connect it to external tools. So in the future, if you want to connect to documentation, that's something we could do. And the rest of our stack, we used React for our front end. We used auto libraries you could see on that workflow slide to kind of go through that pipeline. And yeah.
Do you see this working alongside or replacing some of the other kind of more classic EDA tools and design tools that are used today?
I think it's interesting to put this in parallel to Cursor. If you were to use Cursor, you need to have some level of software engineering knowledge. If you were to use something like this, you need to have a fundamental circuit design knowledge as well to use it effectively. Of course, you could fiddle around and make something, but you wouldn't be able to use it to its full potential. Is that all? Thank you. Really appreciate it.
Thank you so much. And next up, our team, Athena. Let's give it up for Athena.
Hi, everyone. My name is Lucas, and on the behalf of my team, I am thrilled to share with you guys Athena, our multimodal AI tutor. Let's dive in. First, I want to show you some headlines. AI has promised great strides in productivity, yet at the same time, education outcomes are decreasing across the nation. So how do we reconcile this? Well, it's not all bad. AI promises huge productivity boosts for education as well. In fact, a Harvard study found that students using AI tutors doubled their learning outcomes while requiring shorter sessions. So why isn't that currently happening? Well, let's dive into the current solutions and maybe where they're going wrong. If we look at providers like OpenAI and Anthropic, they've started exploring education spaces, but it's simple chatbot interfaces, it's not quite immersive. Even more tailored solutions like Notebook LM with some multimodal capabilities just don't quite hit the target yet. We think that we need a big breakthrough to take AI education to everyone, and that's Athena. How can we utilize AI learning capabilities to reimagine human-computer interaction when it comes to learning? With Athena. So let's dive in. Athena is a super customizable, interactive, modular canvas powered by our voice assistant. The first step is uploading your context. You go ahead and upload lectures, you upload papers, you upload anything you need to provide context. And after that, our voice assistant takes over, and I will show you our demo now. Can we get some volume? Okay, well, you'll just have to believe us that we're actually talking to the voice agent. I promise we are. It's pretty quick, and in the background, it is connected to many tool calls that allow it to generate different types of content. Like the first thing it's going to generate here is a study guide. Once you've gone over that study guide and maybe have some grasp over the knowledge, you can ask it to generate a quiz. And in fact, that's what Daniel is asking. And in addition to that, we have so many more tools that it's connected to. We have the ability to generate quizzes, interactive artifacts. We can generate visualizations, diagrams. We can generate animations. So we have video capabilities, voice capabilities, text capabilities. But that's really only the start. A really cool feature we have is the desktop view, which connects let's say you're working on your math problem set on a piece of paper or a tablet. It connects that directly into Athena via a video feed and can provide live feedback and correction. Here's a basic overview of our architecture. We make extensive use of the VOPI platform to power a voice assistant, equipping it with the tool calls we need to generate context and manage the layout. Furthermore, those agents are powered by Gemini's native voice capabilities. And Gemini also powers the rest of the stack, including writing code to generate a lot of those visuals. All right, so this is the team. We're all from Davis, Daniel, Atin, Niels, it's his birthday, so he's not here, and myself. We met at Hack Night, this cool event, and we've been friends ever since. But let me tell you a little bit more about the vision of Athena. Our visions are grand, but rooted in real feedback. And in fact, already by talking to judges, we found use cases that extend well past education. Our judges expressed interest in using this for their enterprise applications, like onboarding. Anything where you have to collect knowledge and provide immersive, personalizable experiences. And let me tell you a little bit more about personalization. Using metrics, by showing our users different modalities, we can learn which modalities are uniquely tailored to each user, and without relying on expensive methods like fine-tuning or things like that, we can nevertheless provide gradually increasing, personalized, customized, tailored experiences. We believe that student and everyone's engagement is critical to boosting productivity, and we believe that Athena will provide just that. Thank you.
Yeah, what sort of preference data can you collect to improve the application experience over time?
Yeah, so there's a few things we can point to. One is just time spent engaged with different modalities. Since this is a really natural discussion with an agent, it's super easy to seamlessly switch between different interaction types, and we can track which interactions users spend a longer time with. But it really doesn't stop there. Another important feature is the use of quizzes to verify that this learning is actually working, right? So you can imagine a system where we teach with different methods, collect the information in the quizzes, see how well the students are doing, and use that to tailor the system further.
It's just like adding on to that, like you mentioned, like the quiz accuracy score, we can see which forms of learning tended to actually create higher accuracy on those quizzes, creating benchmarks and like kind of like optimizing what like learning modalities would be best suited for like the general public, but also just for the individual user. And from there, we can start tailoring user experiences from there and collect a lot of data on learning habits, even helping schools potentially.
Good job on the presentation. There are a lot of noise in this space currently with the AI and education. So how are you thinking about going distribution and making the first adoption for your initial customers?
Yeah, I think that's a great question. And I think the key is playing to our strengths, right? We're college students. We attend UC Davis. We're often in lecture halls that are filled with 200, even 300 students. And in those spaces, we see firsthand the sort of challenges that students face when it comes to education these days. So I think our perspective as students will mean that it makes sense for us to really focus on that demographic first. In terms of distribution, our teammate Daniel here, I don't know if you guys know him, he's a content creator actually, so that's definitely gonna help us out. I think we've really seen the rise of these sort of viral distribution strategies, and I think that's something that we'd want to tap into.
Yeah, and just adding on to it, like you mentioned, like we are like the target audience. So we know what the users are looking for, what our audience is looking for, and so we can tailor our own go-to-market and like our own like social media marketing, our like ambassador programs on around campuses. Like we know our market, so I think this will help us like know the approach for our go-to-market strategy better.
One more thing I wanted to add was the sky's the limit when it comes to the domain. We can work with all sorts of ages. We can work with children in elementary school. We can expand it so that it's usable in enterprise locations, like we spoke to some judges. So yeah, I just want to say this, like the domain is just so big for this kind of product.
Can I ask, how can your tool be used to help the instructors of the courses too?
That's a great question, and honestly, I don't think it's something that we've given a lot of thought to. But let me take you back to those metrics. I think as we start collecting more data about the type of interactions that students really engage with, we can relay that very same data back to instructors to help them make their own lectures more engaging. And I think we're already seeing instructors use a lot of like supplemental materials that they connect to their courses, and I think this, we can provide basically a constant stream of data between instructors and students to boost everyone's experience.
Thank you, Athena.
Thank you very much. Thank you.
Next up is MockMouse.
Hi guys, hi judges. So this is Team MockMouse and we present for you MockMouse, which is cursor for QA. So I just have an honest question. So in today's hackathon, how many of you guys just did like accept, and then just hoped, let's hope it works, and it worked. But what if it didn't? Like, what if there was some scenarios where it was breaking and stuff like that? So for that, we present cursor for quality analysis testing. So what is the problem? Like, why do build automated QA tool? So around 60 to 70% of QA time is spent by manual QAs in all the startups, in all the SMEs and mid-sized teams. And 30% higher error rate due to people doing it manually. So obviously human interactions, right? We are going to, like miss out some things. Those things will turn out to grow and, become some like big problem for us in the future. And third was 50% slower release cycles. So think of it, like you build pretty fast, like shipping fast is a thing in SF, I hear. So you build pretty fast, but then it breaks. But let's ship it and let's make sure let's not break it. So we will make sure that all the release cycles will be pretty fast if we set up automated QAs. So like we have cursor like for code, we have like cursor for sales, marketing, then why not for the most important part, having it work properly for you to do all the sales. Going ahead. So what do we offer? So we have AI-powered test generation. So in simple words, you can write your tests in simple, plain English. So you write your tests in simple, plain English, and our intelligent orchestrator will break those down into proper agentic steps, which will go to browser use, and then browser will implement all the tests for you, and then provide you with proper results. We also have performance analytics. Like when a human or a QA does any testing, like that human being cannot really give you performance analytics and then LCP rankings and how does performance work, what was the load time, etc., etc. We also provide you with those kind of analysis. On top of that, we have real-time monitoring. So when the test is running, you can also get a recording of that, session of that, and also live streaming of like seeing what your agent is actually dealing with. And then full application context. So obviously we are not building like SPAs, right? We are building something really big. It has to get a lot of context. And it can't just be clicking off the browser and going ahead. So what we have is application context, which will carry the complete portable memory of the application all throughout all the tests and do comprehensive analysis before going ahead and running all these tests. So how did we build this? So the major part in this product was played by browser use. So we self-hosted browser use and used it for our main interaction with the web applications. Then Next.js and Express for front-end and back-end. We wrote complete infrastructure in Python because that was the most well-suited thing to go with browser use. Supabase for our database, and then we used Claude for all of our agent orchestrations, deductions, and also with browser use. Meet our team. So myself, I'm Jay, Saloni, Teerth, and Khushi. Excellent team to build with. We really built it in past 24 hours and we were able to deliver it to you guys. So yeah, this was MockMouse, this was the demo. And if you guys really like the product and are interested about it, you can check the demo live on this YouTube link. And if you guys are more interested in discussing how did we pull it through or if you want to use it, then you can schedule a call with us on this link. Thank you so much.
Could you describe how tests are composed and executed?
So to give like a overview of this, okay, you write a test like, okay, test auth flow or test login flow, test search functionality. Now this line is taken, this plain simple prompt is taken along with the entire context of the application. The context is driven through various ways, like there are screenshots taken, browser used to take screenshots and analysis of them with like GPT or Claude, in this case we're using Claude. And then along with all of this context and the prompt that we passed, it comes up with a proper orchestrated steps, 7 to 8 or 8 to 10 steps of how to actually go around the browser and click that particular things and see if it's working. Keep in mind around the entire memory of this thing. Okay, like in some places this button would work in this way, but for this application context, we want to work it in this way. It also holds that for us.
Is there a specific type of user you guys are built this for, maybe, or type of team? Maybe small QA teams or people without QA teams?
So we would really like to focus on all sort of teams going ahead in the future, but obviously like we don't want to like start, rush and go fast. So starting, we want to focus on fast-moving teams because, I have seen a lot of teams, a lot of SF teams, or, they believe in building fast. And while they build fast, they somewhere miss out on the fact of building perfectly. So why not provide them with a tool? Because let them build fast, but we'll provide them with a tool as well.
There's a bunch of automated QA products, like Spur is one that's pretty similar to this. I'm curious, when you looked at the competitive landscape, what did they miss?
So I think the most important thing is like a conversational flow. So what we are trying to offer is not like, okay, like you put a test, you get results and it's done. What we want to offer is like a natural agentic conversation. We really don't want to make it feel like you're talking to a tool. We want to make it feel like you're literally talking to a person who is on your team. So that brings me actually to my future scope, which is like, we have 3 things in our future scope. First is Slack integration of this. So you could literally tag @MockMouse and then ask it, like recently Cursor launched their @Cursor to directly run background agents from Cursor, like Slack. So we'll do the similar thing, like @MockMouse, run this test for me and it will give you all the test results. Secondly, it was uptime checkers. This is something a lot of QA testing apps don't have, according to me. It's like every 12 hours, every 24 hours. A lot of big businesses miss out on millions of dollars of revenue if they are down for even 10 minutes. So how about like we have an uptime checker every 12 hours, like any custom duration, any custom period the user wants to. And the third thing is running this on all kind of CI/CD, any push or anything. So like giving every layer of flexibility, starting from PM on the team to the developer on the team.
Thank you, MockMouse. Give them a round of applause. Next up, we'll have the 3 projects for the creativity track. For these tracks, we'll have the judges present 3 questions after their pitch. Thank you. Next up is Dawzy.
Hello, everybody. Raise your hand if you like music. Yeah, let's go. Yeah, all right. We are Dawzy, your AI assistant for music production. So for anybody who doesn't know, a DAW, a DAW is a digital audio workstation. It's how beginners to professional creators produce music. We noticed in existing DAWs that they have too many complex menus. Plugins are hard to navigate, especially for beginners. There's a very steep learning curve, and we aim to eliminate that with our product here. So there are existing AI music solutions. However, we notice they're way too automated, and in my opinion, they take away the fun, the ability to edit and tweak these tracks that are autonomously generating. So introducing Dawzy. This is what we came up with. It's a middle ground. We use AI to assist, not to automate. We're aiming to have efficient communication in real time while you're working on your music. So here's a quick 2-minute demo where we cover most of our main functionality. Our integrated AI assistant within our music production software. We offer multimodal communication with our Dawzy agent. For example, let's say you've been hearing a melody in your head the whole day, but you don't have the technical experience to get it into the production software. You can simply hit record. Da 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 da. You can see that Dawzy automatically populates all of these converted MIDI tracks directly into our music production software. Hey, can you generate me an 80s jazz fusion track with a trumpet solo, please?
Generated music track, beat.wave, Parameters used, genre jazz.
This live generation is possible through our open source API, Beethoven AI, which takes OpenAI generated specific prompts and turns them into live AI music generation. Next, can you edit that same track and give it both reverb and delay as FX?
Perfect. I've successfully added both reverb and delay effects to your Jazz Fusion track.
Dawzy doesn't
This will
replace
add
your
echo delay
creativity.
effects that work great for Jazz Fusion, especially for that trumpet solo.
Thanks. I decided I actually don't like the delay. Can you remove the delay, please?
Now your Jazz Fusion track only has the reverb effect remaining, which will give it that nice reverberant space without the delay interfering with the natural flow of your trumpet solo.
Can you go through every single knob and adjustments in the reverb menu and tell me what each of them do?
Complete reverb parameter guide, every single control. Here's what every single knob and adjustment in your reverb on the Beethoven Jazz Energetic track does. Here are a few quick and effective techniques you can try to spice up your jazz track. 1. Add chord extensions.
Dawzy doesn't replace your creativity, it amplifies it. Please feel free to ask any questions about how it's made.
Great demo. I guess elephant in the room, how are you thinking about IP and copyrights?
About what?
IP and copyrights of the generated musics?
Well, the user is generating the music. We aren't copying it from like anywhere.
Right, but you're leveraging cloud or OpenAI, so some data and.
Oh yeah, we are using OpenAI's LLM and Claude. So we haven't really thought about that yet, but this could be, we can use an open source model, Llama. It can perform the same way, because for the music, we are using a separate open source model that could be used commercially.
Got it. So the user's gonna own the music generated?
Yes, because the user is generating the music. It just like removes the barrier to talking with that complicated interface. That's the main goal.
Yeah, so we implemented conversational memory. So as you continue to use this software, it's going to remember your preferences. It's going to remember what you did generate, what you liked, what effects you put onto it. And we store a lot of that locally. In the future, right, it would be on a server or in the cloud or however this product would work. But right now we have it locally, and that allows for future creations. It's pulling a large mesh of drum lines, different instruments that it knows you enjoyed. So I don't think we'd ever run into issues with copyright, since most of it is largely being generated on the fly.
So I guess related question, which you say here OpenAI controls Beethoven. So can you explain a little bit, is your app prompting OpenAI, which controls another generative model, which actually produces the audio?
Yeah, so since our main Dawzy integrated agent here is controlled with the conversational memory and by the user, we'd like to keep that by itself so that it has all that memory. And then we have that internally in our backend, creating a list of very specific instructions, everything from BPM, key, what instruments to use. Just from the one sentence, can you generate me a jazz track? It takes all that information and makes a custom prompt that is designed to feed into Beethoven AI.
So Beethoven AI, so you write prompts to Beethoven AI. And
Yeah,
Beethoven
exactly.
AI gives you actual.
Yeah, we do, we're simple, we don't know what we're talking about. Sometimes we give it a simple prompt, our agent will turn it into a complicated prompt, which is fed into Beethoven AI, which is then integrated to upload it directly to the DAW software.
And then you generate multiple tracks with Beethoven AI that are overlapped, or it's always a single track?
Yeah, they overlap, or it depends. In this case, I asked for a drum line with a trumpet solo. So as you heard, it added drums and a trumpet. It does overlay them in one stereo wave file here, but we don't have proof of it, I guess, but we have generated just consistent bass notes and then a guitar, and you can have layers and do it as you normally would produce music.
As an Ableton Power user myself, I love that you're building in the category. My question is, to use your product, do I have to use your specific DAW, or can you integrate with, be it Ableton or the others?
That's a great question. That's actually, honestly, the major thing that we were thinking about when building this the past 24 hours. So right now, as an Ableton user, I don't know if you're familiar with Reaper, but it's another existing DAW. I also use Ableton myself. Reaper is what we decided to use for this project because it is highly scriptable. So for a prototype, we can have Claude directly generate these, or Reaper provides tools through an API. So Claude can generate these dynamic scripts that create music and add effects and delete tracks and anything we need it to do. In the future, we definitely hope to implement this widget style into every existing music production software. But as a long-term goal, our final product would be hopefully a DAW itself, which is designed to have a low barrier of entry and coach people along the way and not be bombarded with all these dials and buttons. Yeah, so we'd hopefully have a simplistic UI in the DAW, and then in the chat it would pull up like dynamic sliders and say, I noticed you're making a jazz song. Here's a reverb slider for as if it was playing in a jazz concert hall. Feel free to adjust it on the fly. So that's definitely the long-term goal.
Awesome. Thank you.
Thank you guys.
Next up is Readme.
All right, so I have a question for the audience. Have you guys, show of hands, how many of you guys have tried to read a research paper and couldn't get beyond the abstract, or, okay, or barely understood the abstract? All right, so I see the hands. All right, so basically that was the inspiration behind Readme.ai. So basically we want to make research more accessible. So next slide. So here are the pain points, right? Scientists, especially researchers, but people in general will spend a lot of time reviewing these research papers. But these research papers or literature, academic literature, aren't really made with novices in mind. And that creates a huge comprehension barrier that often causes a lot of people to give up before they're even done with the abstract, right? And so that's why we created Readme AI, built by us student researchers for anyone who wants to learn. What makes us unique is that we focus on video generation that's grounded in scientific research papers that we're trying to understand and not bullshit, right? And we're gonna have that.
So here's a look at our UI. Obviously, there's a lot of components that we'll get into later, but the meat and potatoes is our video generation stack. Who here has heard of 3 Blue, 1 Brown? How about Khan Academy? Yeah? So we generate AI-generated videos much in the style of 3 Blue, 1 Brown and or Khan Academy. So let's take a look at a clip from one of these videos. Hello? Oh. Oh. Can we get a click on that?
In 1998, Larry Page and Sergey Brin faced an audacious
challenge. So this is the original paper that Google made that powered their original search engine. We can also do much more complicated animations. So here's a sped up version of this without any voice. Completely AI generated.
And all with upload of a research paper.
And then if we run out of, or if it's too hard to generate animations like this, we fall back to Google's VO API for more complicated, more realistic animations. Can we get a click on this? Yeah.
The key insight is that accurate binding affinity prediction requires understanding.
Here's our video generation pipeline. We take a PDF, we put it into Claude, then it goes into Manim and VO and a voice API. It also goes into FFmpeg and MoviePy, and it gets all stitched together into one nice, beautiful video for your consumption.
But wait, there's more. What if you want to learn in other ways? We have a key concept summary for key concepts that you want to understand. We also have, if there's code on the paper, we can extract it and give it an easy way where you can interact with it with the README file. And lastly, we even have a quiz that allows you to test your understanding.
This quiz was generated from a biology paper. I'm a math and CS guy. I know nothing about biology, and in just a 5-minute video, I was able to learn quite a bit about this biology topic, which is sort of an open source AlphaFold, yeah.
So here are some of our next steps. These include open source deployment, creating a crowdsourced library of videos, as well as creating a chatbot to help our users understand their papers better. Thank you for listening. And who's ready to go?
Beyond the abstract.
I'm curious, do you think that this will save people time or really more just actually engage them enough to get through it, or is it both?
I think it certainly could be both. There are definitely cases where you may just get a good enough understanding from simply the video that it generates, but there also may be cases where it sort of bridges the gap between you and a paper that may be sort of beyond your reach if you were just reading it by yourself.
One thing we want to add is I feel like recently, especially with a lot of technological advancements in AI, a lot of papers have actually been going viral, and there's a lot of discourse on things like Reddit or Twitter about these papers, but we think something like this can really help bridge any gaps of understanding or prior knowledge and bring everyone to sort of the same level of understanding.
Can the tool summarize a group of papers? So sometimes we might have a set of literature that's not always in full agreement. And what does the model do in that case?
In the current state, no. But really, this is a couple lines of code to change this in the Claude API. So, yeah.
And then right now what we have is when you run a paper through our tool, you can also store it. So I don't know if you saw in our UI, but we had a library of papers that we were testing our tool out, and we had multiple papers. So this is definitely something where it's not just related to one source at a time, but you can compare multiple videos.
Thank you, Readme AI. Next up is Cameron.
Good afternoon. We built Cameron, and we're super excited to demo the Cameron to you today. AI has transformed much of the digital world, including code generation, video generation, and language. But the physical world lacks connection to AI. And that's why we built Cameron, because we believe the future of AI connects to the physical world.
Okay, so how we went about making this is we have a series of nodes where you can connect any input to any response. So basically, you tell the camera what you want it to see and what you want it to do in response to what it sees. And we've made this really sleek and convenient UI here. It's a series of nodes where you can connect the input node, the video feed, into any one of these detection nodes where you can specify in a prompt, in natural language, what you want to see. If you want to see a person, identify people with red shirts, you write it in there, it's going to detect it when it finds it in the video feed. And then you can pipe that response into any of these action nodes. So if you want to send a Gmail to yourself or to your friend, or you want to give yourself a call in case any kind of trigger happens, it can do that. So anything you want to see, it can tell you about, it can notify you about, and it can act in response to.
As you can see, there are limitless applications, not only serious one, but also more silly one like notify me when my mom comes home. And once the event is detected, MCP can automatically send notifications to users through customizable channels. such as email, voice call, but also like more unique one like geolocation-based notifications.
Yeah, so this is one of our use cases. We're basically watching like an elderly woman at a hospital. We're trying to detect like heavy breathing, and if we were to do this with like an actual like nurse, it would take like so much more time and effort. And this one is like a living room CCTV. So parents are like really busy. They can't like watch their kids all the time. And basically Cameron would be able to like alert them immediately in real time if their kid is in danger. And then our third use case is this robbery at a bank. So like the bank teller wouldn't be able to like call 911 themselves because it'll like put them in like more danger and risk. So Cameron would automatically call 911 for them through VAPI.
So a funny story, the other day we were going out to lunch, right? And we come back and all of our seats were taken, even though we put our stuff there. So basically we got squatted on, and we wanted to build, we thought this was a great situation where we could build this like anti-squatting app where it would actually detect who's sitting in front of your computer screen. So like if you left your stuff there and somebody like just happened to swoop in and take your computer, you would be notified of that. So here it's able to detect, that's me, so everything's chill. And here's Andrew. So Andrew's not in the database, he's not in the registry. So it's gonna flag red, it's gonna notify me. So it uses VAPI to call me so that I can come over there and handle the situation. So essentially, like, you don't want, like, there's so many use cases for this and so many tools you can attach to this. We've built a framework where you literally just ask a camera to look for something and do it, and it's gonna do it. It's gonna handle all of that stuff for you.
Yeah, so we're really excited to develop this project further, and if you're interested in like following along our journey and like get notified when we actually launch, feel free to scan this QR code, and thank you for listening.
Okay, any questions?
Yeah, so does it work with any camera, or does it need to be a certain like CCTV camera, or do you have to build integrations for each type of camera?
No, any camera, as long as you can get it into a video stream, you can add it, and it's going to, the LLMs are going to be able to parse that stream.
So related to that, can it pull, for example, from Google Nest application, Google Home sends a stream, can you pull automatically from streams like this?
So, yeah, so as long as we have a source of that, like anyone can build a connector to it. So we haven't used that per se, but we've actually had custom tooling for Gmail. Those are the kind of things we've used. So you can build your own tools or you can source it from there.
Then in addition to alerting someone using some of the telephony channels that you described, what is the possible like set of actions one can take based on the visual intelligence? Like maybe you could give a few examples of interesting things.
Yeah, I think the actions, it could be pretty limitless because we integrate MCP, and MCP has tons of integrations right now. But some common examples is like calling 911 or calling your friend. But we've also thought about other examples. For example, you have like a camera facing like perhaps your kitchen, and then maybe your cookies are like cooking. So then maybe it'll alert you right when your cookies are like perfect. Or another example that a different CEO at this hackathon told us about was you have the camera facing like the office door coming in, and I guess the boss couldn't see who's slacking or something, and you could model it over time and see what happens. Yeah, so like that could perhaps have like MCP integration with like Google Sheets. Yeah. Any more questions?
Have you thought about business model or monetization?
We thought about it like a little bit. Essentially, like there's like it's like a $60 billion industry, right? And we aim to just cut costs. So as long as we can make things more efficient and make things cheaper, that's like the goal for us.
Thank you, Cameron. Next up will be our 3 projects from the social impact track. So I'm very excited to welcome Gather, who is our first project. Let's give them a warm round of applause.
Humor me for a second. I'd like a couple people from the crowd to just raise their hand for me. I need a little help from one volunteer. You, right there. Can you stand up for me? Do you think you could tell me about one issue or cause that you feel really strongly about? Can you say it a little loud for the crowd?
Like making education fun.
Making education fun. That's a perfect example, right? We're here at Berkeley. That's the place to be. So, something that I wanted to talk about, for example, would be deportation. And that may seem a little bit out of nowhere, out of context, but I really wanted you guys to take it seriously and bear with me for a second. I met an individual this past year at Berkeley as a freshman that became a really pivotal figure in my life. And after 6 months of knowing him, I came to know that he was here as an illegal immigrant. And I became aware of the struggles and the fear that he lives in every single day. And I became aware of a gap between sort of what I wanted to do to help him and what I knew how to do to help him.
Overall, there's so many problems out there, but we don't know what to do or how to get started. And that's why we created Gather.
My name is Nick Srivastava.
I'm Nidhi.
I'm Dia.
And I'm Kedar. Now, let's get straight to it. Back. That's good for now. All right. Our goal, our number one product, when you want to understand something in the world, let's say climate change or education, how do you get started? It's through research. It's through educating yourself. And that's what we wanted to do to start. We used the Leda API, the agent development environment, in order to set up a pretty detailed Google search system where we would find the 4 most visited sites about a specific query, as specific as it could be, and find all of the empirics from it and generate an article, a very detailed article that tells you everything about that topic that you need to know to make an informed decision about donating. That was our ultimate goal. We used Claude Whisper, which is the best writing model, I think, out there, to go and create that article. And what do we do with that information, right? How do you actually get started? Well,
what does the action really look like? Things like petitions, fundraisers, and even volunteering events are some of the ways that you can make a tangible impact on the causes that you actually care about. But rather than having to go on the website and manually scraping this yourself, our platform uses automated web scraping along with a Playwright web browser integration to aggregate data from websites like change.org and petition.org, and then create a curated list of opportunities that users can then take to go from awareness to action in an instant.
One of the major features we want to focus on in our app was community. As we all know, talking about the things we feel most passionate about with people is one of the best ways to learn about it. That's why we created forums for the people using our platform in order to talk about the issues that they care about. However, we wanted to create something like Facebook for you to create the issue, like talk about the issues that really matter to you, but we did want to add something a little bit more, which is why we use Grok as an AI inference to read through the chats that you have with other people on our platform to learn more about the issues that you care about and recommend things for you to do about those. So for example, if a lot of people in a certain community talking about volunteering or want to fundraise for a school that might be shut down, the Grok AI will automatically infer that you would probably want to set up a petition or a fundraiser to set up to save the school, for example. So through learning from these chats and the interactions it has with the people in the chat, we used AI to kind of recommend petitions and links for the people to go to so they automatically can take action without having to go to external platforms.
And right here, we have sort of a voice assistant. Unfortunately, the video was not able to be displayed. But we used Vappy, and Nidhi and I here actually ran a hackathon a little while ago together, where we sort of created learning agents enabled by 11 Labs and powered by Perplexity Sonar. And we really wanted to extend that sort of accessibility. That was originally intended for learning for the differently abled, but we really thought with Vappy here today that we'd utilize that API again to sort of create a unique experience for learning and automation. And that's why the whole app, through a combination of Claude 4 on the back end of Vappy, as well as the 11 Labs voice, plus Playwright integration, which we were inspired by Unify's workshop, enables us to make complete tool calls, traverse the website, search, everything, all using our voice. And we could, for example, in this, I believe we're talking about machine learning and cancer research, and the agent is giving us some context. But we came together to build Gather because we believe that the idea or the concept of taking action is a lot more daunting than taking the action itself. And we would appreciate your support in joining us in that belief. Thank you.
All right, we're open to questions.
And so is the biggest differentiator from some of the other search places to search is the community aspect? And I guess could you elaborate what other features or call to actions you guys could build?
Yeah, so I think what the real value of our platform is, it kind of brings everything together. So of course, you visit this platform, like GoFundMe or like change.org. There's only one thing you can do. You can either fundraise or you can start a petition, but here you can kind of go to one place to learn what you can do and also be able to do it, right? That's why the articles are free to get some background information and see what you're really comfortable with doing in order to take action. And it's nice because everything's on the same platform, so you'll be able to decide what you want to do with the information you just learned. And as Nick mentioned, the voice agent is one of the ways for us to think through what you want to do. So ideally, like, you would be talking to this voice agent, and if you, for example, tell the voice agent, I don't feel comfortable, like, I don't feel like donating money or I can't, it'll recommend other ways for you to contribute. So that's one of the ways, like, personalized.
And along with this, I think another advantage that we have is bringing credible sources. Because when it comes to, finding fundraisers and petitions online, there tends to be a lot of noise, a lot of fraudulent and kind of shady websites, right? So we system prompted Claude to return credible websites from credible sources. It was Claude and Meta AI. So yeah, that helps the users in that way as well.
On the educational piece of the platform, how do you think about bias and misinformation, especially with you getting information from Reddit, or even Wikipedia is known for?
Yeah, no, this is actually why we used Letta, because we wanted very specific control. We wanted fine-grained control. Because, the reality of the situation is we can't just scrape every site in the universe that's, remotely related to our query, because it's going to have bias. We actually tried to add a kind of preliminary bias detector as well, so it's in the app right now. But if we were to go further, we would enhance that. There are a lot of models out there and a lot of products out there that are trying to implement it, but we'll definitely have that in the back of our mind. And we'll also make that a very clear disclaimer, because a lot of AI products are trained on, biased data, right? And so making the user informed and educating them along the way and letting them know that this is a tool and that they need to do their own research with credible sources and understand what a credible source is in the first place, I think that's like all the steps we need to do to make that really just responsible AI in like the future as well, not just for this. That's what I would say.
Thank you, Gather.
Thank you, guys.
Next up is PFOG. Let's welcome them to the stage.
Hi, everyone. We built PFOG, and it is a medical device that supports people with Parkinson's. Now, a large problem that people with Parkinson's face is something called gait freezing. And what that is it's a problem that presents itself in daily life. You'll be walking, and suddenly, you'll just stop. You'll freeze. And as seen above, oftentimes it presents itself as sort of a stutter or a shake. And this is especially bad because it puts them at risk of falling and then of injury.
All right, so there was a recent Nature paper that showed that if you mechanically stimulate the muscle that's freezing, it can actually help the patient recover and keep walking during one of these fog episodes. And so this was, really interesting for my family because my grandfather has Parkinson's. And we actually found, after some experimentation, that if we just walked behind my grandfather, and every time he froze, if we just poked him in the back of his leg with a stick, so nothing fancy, it miraculously helped him, recover and keep walking through that freezing episode. And so that's kind of the story of what inspired us for our project today, because we wanted to automate this process and create a product that, one can autonomously predict whether a Parkinson's patient is freezing, and then also mechanically stimulate them to help them recover.
And so a large part of this is actually hardware. So we built some custom stuff over here, including an inertial measurement unit, which is able to track the acceleration and rotation values. It sends it up to an ESP, which then sends it over to computer for now, and then that computes a prediction based off of a custom model to determine and make a prediction whether the person is standing, walking, or freezing. And if the person is determined to be frozen, it'll send a signal back to the ESP, and then it'll continue to mechanically stimulate their muscles until they're able to walk again.
To make the training process simple, we made a web interface that allows you to label the data in real time, and you can select these data sets and use it to train our CNN and LSTM model. Then you can select any of these models and use it on the device to predict a freezing episode.
Okay, so a little bit about the model we used. We used a hybrid 1D CNN plus LSTM architecture. And so the CNN basically extracts like spatial features from the data, and you get about 200 spatial features, and that's fed into the LSTM, which goes sequentially through, and that extracts more like temporal patterns.
And just to add some numbers, in the last weekend, we collected over 68,000 points of data, giving us a 96% test accuracy and a 99% validation accuracy.
Okay, so here's our demo.
So if you look at the demo, basically you can see our interface that's predicting freezing episodes in real time. And if you look carefully, you can see the device mechanically stimulating the leg and allowing the patient to walk freely again.
We're just going to wait for the mechanical stimulation close-up.
We'll have a little close-up. It'll be really cool, I promise. So the servo is going to continue actuating until Shuyi is ready to walk again. And as for next steps, there's about a 10 million population around the world who have Parkinson's, so we want to be able to support their mobility as long as possible by collecting more data from those who have Parkinson's, and then make the setup a lot cleaner, make the enclosures a little bit more easy to use and easy to put on, and make it wireless so we don't have to strap it to a computer all the time. And then maybe in the future, maybe detect and alert family members in the event that the stimulation fails and the person does actually fall. Thank you.
So the problem is from the sensor data you need on device to detect if a freeze has happened.
That's the next step.
Okay,
Right now, the sensor device is sent to a microcontroller, and the microcontroller sends it to a computer, and the model runs on the computer and sends the data back to the microcontroller. And it still happens fast enough that we can, predict and have this actuation happen in real time. But the model, we also made it to be very lightweight, so the next step would be porting it onto like a microprocessor unit that's on the device.
Great. And the CNN data, I understand there's accelerometer data. What is the CNN taking as an input?
As an input, it takes 256 time frames, and we're sampling at like 200 hertz, so that's about a second of data. And then for each of those timestamps, we have 6 pieces of information. It's X, Y, Z acceleration, and then 3 rotational accelerations as well.
Would the signals of a freezing event depend on the patient? In other words, would it have to be trained on each patient independently, or is there something common across patients?
From my personal experience and also from the videos we watched, the general pattern of motion seems to be very common, but actually in our web server, we included features where you can collect more data and keep tuning the model, and so that would be perfect for, making it work for every patient.
What research have you done around the general reimbursement environment for Parkinson's therapeutics, i.e. how are you going to get paid? By an insurer, by a patient, by a provider?
I guess I can take this question. To be honest, we didn't start this project with any intention of making it like a commercial product. It was genuinely just, it works for my grandpa, and we want to make something that can help him walk and help other people walk too. So that would be something to look into.
Thank you, PFOG. Let's give them a round of applause. Our final team for today is called Replicant. Let's welcome them to the stage.
Hello everyone, we're Team Replicant. My name is Shivani. I'm Sahithi.
I'm Hiba.
Yo, what's good, y'all? My name's Nathan. When is the last time any of you guys, just answer this in your head, you don't have to raise your hand or anything. Judges, you two, judges and participants, when is the last time you guys have reached out to, your congressional representative? Now, if you guys said yes, like good for you. You guys are like super politically aware. But if you guys said no, like you guys are in the vast majority of people. Like the majority of people have not like reached out to their congressional representatives.
You're definitely not alone. Legislation only has a 0.1% feedback rate, but there's 100% impact on individuals' lives with said legislation. So I'm going to hand it over to Siobhan.
Okay, so I actually have experience within the public policy space. I've been to the Pentagon, been to Congress this year, and the one thing that I took away from that experience is that the time for AI in policymaking and government is right now. So with that, we're going to introduce our platform, Replicant.
Replicant is an AI-based platform that generates constituent personas based on data. So this data is mostly like live data scraped from the Bureau. So this enables policyholders to really understand how they're impacting their constituents and focus not only on the 0.1%, but also on the 99.9% and really understand what effect their legislation and policy has.
Okay, so this is like a live demo of the website. As you guys can see, this is the landing page, and we went with a very simple UI UX design, so it's a very user-friendly. And you can see the features that we provide, and also there's a button right next to the sign-in, which is watch demo video, so you can play that as well to know how a user will use it.
Okay, so this is how you would make a profile based on your state, the district, and also any congressional committees. So here's me signing in as Berkeley's representative, so we're going to get to the landing page, and I'll pass it on to Nathan.
Yeah, so this is the dashboard. As you can see, we got like some statistics. These are scraped like straight from the US Census. They're not hallucinated. It's an API call. And essentially, like, we're using this information to generate accurate constituent profiles for like a given district. In this case, it would be like the district, like the Berkeley district. So here's like a couple constituents. We'll like talk more about that later. But we can see what's going on with like one constituent in particular right now. And we can ask them like any question we want about like policy. So this is a constituent who is a 30-year-old college student or bachelor student, they're graduated from California. We gave them a prompt about like whether or not we should increase minimum wage, and it looks like they had a lot to say. You know, I've felt personally that they have like a lot of unique insights to offer. It's cool stuff.
And like over here, you can see that if you guys want to know about a specific policy or a bill that just passed, then you can just upload a file over here. Like we just uploaded it. You can also type it in if you want. And immediately it gave you a summary, like a short summary, a concise summary of what the bill said.
Yeah, so the summary is going to be based on your district and your state, so it's going to be within that context. So representatives can actually tell what they need to make political and decisions. We also have a policy analysis, like a policy brief that gives you some priorities where you can push that into new policies and represent your constituents better.
Yeah, oh wait, okay. Onto the tech stack. So this is like a drawing I made. It's pretty fire. Like, there's the React front end. We use React and Tailwind CSS for the front end. It connects to a Node.js and Express backend, which pulls data from census.gov and then it sends that to Anthropic AI to generate our constituent information. So essentially, the meaning behind that is like, we pull data from the census about like median income, like age demographics, race demographics, occupation demographics. And then when we make like our 20 constituents, that's essentially meant to like serve as an accurate representation of all the different demographics that make up like a given district. And then for the chat, we use Grok. It's like, it actually is blazingly fast. Like that's a term that just gets thrown around like crazy, but like, we low-key thought it was fake. Like, it's just like, it's like split second. Grok, please, like, yeah. And then we use Supabase for the, just like cache like API queries and stuff. Anthropic, we were running into like some like rate limiting. So Supabase was like really helpful with that. They have like some great documentation. Their interface is like super cool. And yeah, that's the tech stack.
Okay, so what's next? We really believe that Replicant can also be useful in the business industry. Like, companies can use it to understand how new laws might affect them and even like spot loopholes early on. And even at a global level outside of US, we think that UN can also benefit from this. Like, they could use similar digital profiles to guide fairer and a more effective policy making.
But don't get it twisted, we're not trying to cut out the human voice at all. In fact, our goal with this is to make a more inclusive environment, one where policymakers can understand the needs of their constituents. That means workers, teachers, students, you, me, the 99.9%. We hope to create an understanding of what legislation will have an impact on and who it will and how it will have an impact before said legislation is even passed. This is the future of creating inclusive, data-driven, sorry, my words are tripping, data-driven governance. So let's see where we can go with the 99.9%.
Okay, so I hope you guys will reach out to your congressional representatives after or use Replicant to do it for you. Thank you guys so much.
We'll now be accepting questions from the judges.
So to understand, you take a census and you say, this is the age group, like how many people are from this age group, this education, this race, and so on, and then you prompt Claude, how would a person with these properties respond to this question?
Yes, exactly. So there's like a given amount of people like per like a given demographic category. And then so we want to make sure that when we're creating like our constituent agents, that like every category is as accurately represented as possible.
Right, but how do you know that Claude is now correct? How do you, like, I understand making sure that there's exactly 50,000 males of this education, of this income in Berkeley, that you can get from census.
Right.
But then how do they respond about rent control? How would you check that? Okay, Claude says maybe 40% of this demographic slice support rent control. How would you go, you ideally want to go back and check if they indeed asked the Berkeley 30-year-olds that question, if indeed 40% supported rent control, right? That would be a validation that indeed what you're creating synthetic people, right? So you would want to check that the opinions of these synthetic people match real people in some data.
Right, exactly. And I'm glad you brought that up. Like, as my teammate was saying, like towards the end, you know, like Replicant is like by no means intended to be a replacement for like actual human voice. Like, that is like, that's not questionable. But, you know, the truth is like a lot of people, like myself included, are like too busy to actually like show up and petition like my congressional representatives. And so like in the meantime, like Replicant is just a way to ensure that those 99.9% of people who like can't get their voice heard have like some sort of representation. And it's not meant to deliver like true to the book statistics about like how some percentage of a population stand on a certain issue. It's simply meant to demonstrate, oh, like if we were to enact a certain policy, this group, which is represented by like some certain virtual constituent, would be negatively impacted. So it's not necessarily, it is about their opinions, but more so it's about how they're like impacted by the policy. Like how are their lifestyles impacted?
Just to be cynical for a moment,
Yeah.
a lot of politicians react to, based on who's gonna actually get out and vote. And so I'm curious how you think about politicians using this when they might care a little bit more about who's going to get out and vote than someone who, you know, might be affected but ultimately isn't going to actually go out and vote, and so it really doesn't impact the politician.
Yeah, that's a very good point. I think the way we think about it is almost like we're trying to just make this tool in a way that we're able to bridge that gap between feedback. And so we understand like maybe this isn't something that would be directly used, but it still helps them create that constituent profile. In my time in policy, I like noticed how long it took to pass like a simple policy. And so our goal is to basically kind of validate policies before they pass. We're not trying to kind of streamline that process. It's just to validate it and like see what your constituents would think about it.
Thank you, Replicant. Let's give a warm round of applause.
Thank you. Shout out our security guard, Noble.
Let's also give a huge thank you to all the judges who are spending their weekend here judging your projects. They will now deliberate in the back room, and we'll get back to you shortly.
Thank you so much. And in the meantime, we have some prizes to announce, or some winners to announce.
Get hyped.
First up, we are giving all of you the chance to choose your favorite project, which will be rewarded as the Hacker's Choice Prize. So head on over to hackberkeley.org/vote, and you should be able to choose your favorite project.
Cool. So if you did not get that link, it is sent in Slack, so please fill that out so you can vote for your favorite project. Next up, we'll have our lovely sponsors present their prizes. So huge thank you again to all of the sponsors who are listed up here. This event would not have been possible without them, so please show them some love as they're coming on stage soon. So if you are announced, sponsors will be on the stage announcing winners. If you are chosen, please make your way to the backstage, and then sponsors will meet you at the very end to give you your prizes. First up is Inspect Mind.
Hello everyone. So I'm gonna announce the prize for the prize will be the Most Efficiency Improvements Award. $400 in cash. And the winner is Visionify.
Next up, I'm excited to announce Letta will be presenting their prize.
Hi everyone, my name's Sarah. I'm one of the co-founders and the CTO of Letta. So Letta is basically a platform for building stateful agent services in the cloud. So basically agents that are persisted, have memory, can call tools, and live on the cloud or on your own local server. So yeah, we're really excited to be back at Berkeley because we actually started working on MemGPT while my co-founder and I, and also some of our founding team, were working on this project called MemGPT, which was from the Sky Computing, previously known as Rise Lab. So yeah, we were working on that project throughout our PhDs at Berkeley, and now we have a company, Letta, which is basically productionizing a lot of that stuff that we worked on. So yeah, really excited to be back. We had a ton of really incredible submissions. I think we had almost 60 submissions, which was very difficult to go through. And a lot of the projects that we were considering were really impressive. So we'd love to connect with you guys and share them online. But yeah, we decided to choose and then our prize is AirPods with noise cancellation. And yeah, we decided to choose Truly as our winner. So congratulations, and I'll meet you backstage with the prize. Thanks, everyone.
Next up, let's bring Nitro onto the stage.
Hello, everyone. Thank you for joining us. We had a lot of great submissions, and it was great to see you guys all build. So I'll just jump straight into it. The three of us struggled to decide the winners, so we actually added another winner for today. start off with, first is the Nitrode AI Futurist Award, and we actually decided to give it to two teams. First is Neural Courier and Live It. Congratulations. We actually had another prize, which is also the best use of AI to push the boundaries of game dev, which is a $1,536 cash prize, as well as a year's free worth of Nitrode credits. And the winner is Pixelate. Congratulations. Congratulations.
Thank you, Nitrode. Next up, I'd love to invite Bobby to the stage.
Hello, everyone. I'm Dan, and I'm joined here by one of our engineers, Sri. I'm DevRel at Vapi, and it has been so cool to see all the cool things people have been building with voice. We are believers that voice is the next paradigm shift, next iPhone moment of digital experiences, and this weekend, we only got more assured that that is indeed the future. So we have 3 prize tracks that we decided to announce. The first one is, sorry, I don't know how this works. Oh no. Oh well, best voice powered project is VeriBuddy. We will be giving you a cool bag of Vapi swag and a bunch of Vapi credits. We were genuinely impressed with the execution and the quality of the product. Moving on to the next one. Best hardware and voice integration. It takes a lot of courage to ship hardware on a hackathon, especially that short. We were genuinely impressed with the submissions, and this is why we decided to come up with this prize track. So, the winner is ICU. And the final prize track, most ambitious Vapi project. There were a lot to consider, and it was really hard. After a lot of consideration, we decided that the winner is Vocal AI. Your personal AI trainer for singing. Crazy that you can do that. That concludes our announcements. We will be giving you prizes later. Thank you.
Thank you, Bobby. Oh, your raffle winners are up here. So if you are in this audience, please meet Dan and their team at the stage after. Next up, I'd like to invite Orcus to the stage.
Awesome. Hey everyone, my name is Carl. I'm a software engineer at Orcus. I recently joined this year, and this is my first hackathon ever since coming back from college, and it's been really exciting working with all of you guys, one-on-one during our workshop and one-on-one during the mentorship time at our table as well. And what I was looking for you guys, how do you guys best use Orcus in your product? How do you actually use a workflow, specifically, ideally an agentic workflow? And how do you integrate that best in your application? So I had a few submissions, I looked over them pretty intently, and we have a winner. And the prize for today, feel free to meet me later after the stage, and so I can get your email, because we're going to be emailing the $200 gift card to you guys. But the winner for the Orcus track is Octavo.
Thank you, Orcus. I'm very excited to invite Grok to the stage next. Let's give them a warm welcome.
All right, hello. First of all, thank you so much to Flora and the CalHacks team for setting up this awesome event. We saw a huge amount of people using Grok. I think we had something like 70 teams use Grok in their projects. So it was a very tough decision for us to figure out which team to award the Best on Grok prize to. So the prize for the best creative use of Grok is $500 in API credits, We put your project on all of our socials, you get an office tour with us, and you get a guaranteed Grok internship interview. So drum roll please for the Grok track winner. Congratulations to Employ AI. Just feel free to come by and just find me so that I can get your emails so that we can get you into the interview process and coordinate how you'll visit the Grok offices. Once again, thank you so much.
Thank you, Grok. I'm very excited to welcome Unify to the stage next. Let's give them a warm welcome.
Hello, hello. We're Unify. Unlike some of the other sponsors, we didn't have an API for folks to use. We are a B2B company that helps other B2B companies sell their product. So instead, our challenge was the best use of multimodal AI agent, and our prize, $2,500 cash prize, and direct to on-site for a job at Unify. Our winner, we were very impressed with the practicality of the application as well as the stability and the real-world use cases for it. Drum roll, please. The winner of the Unify prize. Mayday. Congratulations, Mayday team. Come meet us in the back.
Thank you, Unify. Next up, I'm very excited to welcome Noble Era and Berkeley RDI to the stage. Thank you.
Hi everyone, it's great to see you here. We're Nobel Era. Backed by Nobel family offices, we are looking for the next Nobel Prize winners and the next great entrepreneurs that build the magnificent enterprises. And we are very glad here. There are so many talents here, which are all our targets. And me myself is also a member of Berkeley PhD and also a member of the Nobel Future Tech Club. And it's great to be here with you.
Yeah, thanks so much. I'm Michael Skahursky. I'm a neuroscientist at MIT. My research is on doing brain simulation, like how can we record from all the neurons in a brain and use machine learning to determine causality so we can replicate consciousness in software. And I'm really grateful to Noble Era for providing me with a lot of opportunities, a lot of financial support. I got connected with them, I took their IQ test, and now there's a lot of support for meeting lots of cool people, a lot of interesting collaborators and other founders. So yeah, I'm really excited about that. And yeah, I think we're going to announce some prizes now. So first for our Pioneer Award, which is $500, that's going to the Team Dream Director. And second, we have our Trailblazer Award for $1,000, and that's going to Team Cameron. And finally, our main prize, the Pinnacle Award, that's $2,500, and that's going to Navi. You can pick the prizes up after this. Thanks so much.
Thank you, Noble Era and Berkeley RDI. Next up,
Congratulations again to all these teams.
1 second. There you go. Next
Google.
up.
Hello, my name is Aziza. I'm part of Google Cloud Vertex AI creative team. So I'm excited to be here. Thank you so much for everyone who submitted their best use of Gemini. And I love seeing everyone utilizing Gemini in their other projects as well. So, tons of submissions. We decided on this team because we really liked the way this project utilized ADK, Lyria, Gemini, Imagine, and VO. So our winner, as you already saw, Google Pixel Watches will go to Dream Director. Thank you so much. Thank you to everyone who participated today and continue to use Google Cloud. Have a great day.
Thank you so much, Google. We're very excited to welcome Fetch AI to the stage next.
Thank you so much. Hi, everyone. I'm Mike Krabash from Fetch AI, and I'm here with Jemai Magahankar. And before we hand out the prizes for the Fetch AI, I'd like first to thank all of you for coming out to the UC Berkeley Hackathon. We were so impressed by the innovation and the creativity. And a big shout out to the 42 teams that used Fetch AI in their projects. We're looking forward to you using Fetch AI in the future. And now for the prizes.
All right, first up we have Best Use of ASI1 Large Language Model with a prize of $1,500 in cash. That goes to Mayday. All right, next challenge was Best Deployment on Agentverse with a cash prize of $750. And the winners are Alpha SQ. Okay, last up, Best Interoperable Agents. Again, same cash prize. All right, Higher Science. All right, congratulations to winners.
Thank you, Fetch AI. Last but not least is Anthropic.
Hey everyone, we're Anthropic. We're the folks behind Claude. It was great to hear so much about what you guys are using in your projects and how you guys are using Claude. If you guys are interested in knowledge, resources, and partnerships with Anthropic in the fall, particularly for you Berkeley students, we'll be around. That being said, our track prize, Best Use of Claude 4, we're giving out 2,500 in API credits.
And the winner is EduAgent. Yeah.
Thank you again to all our wonderful sponsors who made this event happen. We now have the CalHack special prizes to announce. Thank you all for taking the time to vote earlier today. Those prizes are, first up, the best beginner hack. The winner of this prize gets AirPods, and the winner is Bear. Well done. And we now have the best hardware hack, and the winner is ICU. Hopefully we see you in the crowd somewhere. And last but not least, the award you all got to choose, we have the Hacker's Choice Award, who win these wonderful custom backpacks, and they are PFOG. So well done to PFOG.
Up next, we'll be introducing the grand prizes. So if you are called up, please walk up these stairs, or those ones, whichever's closer, up to the stage, and we'll take a photo after. First up is Developer Tools and Productivity Track.
Oops, hold on. Okay, so for the first category, Developer Tools and Productivity Track, the big prize goes to Chip Chat. Congratulations.
Would Chip Chat like to join us up on the stage?
They're coming? All right. You went very far. So congratulations. It was a great project. We like the use case. We like your stack. Congratulations for everything. This is your one. Congratulations. Yes.
All right, and now for the winners of our creativity track, we have winning $5,000 in cash. Next slide. Cameron, well done to Cameron. Does Cameron want to give us a wave from the audience? Alrighty, come on up.
And finally, our social impact track.
Last but not least, the winner for the track is PFOG. Our judges really loved the personal story and data-driven approach of PFOG, so congrats.
We have a big announcement after this, so stick around. And now for our one more thing. Drum roll, please. CalHacks is going to the Palace of Fine Arts. So CalHacks 12.0 will be coming up in October on the 24th to the 26th at the Palace of Fine Arts in San Francisco. We'd like to encourage all of you to come and join us for a wonderful weekend of hacking in a very beautiful venue. Join our email list at hackberkeley.org and follow our Instagram for updates. We'll be joined by many sponsors, including Anthropic. So thank you to Anthropic for helping make that happen as well.
Thank you so much. And so before you head out, please make sure to pick up the trash near you, check your valuables, make sure your phones are all on you, and return any hardware that you borrowed. And remember to check your ID if you borrowed any and left it with us. If you want a prize, please come up to the stage now. And it has been 2 seconds since we started. And so until next time, see you all.
See you at 12.0. Thank you so much.